Let's do 5D. All right, so let's do 5D. So it says 3.90 times 10 to the fourth grams of water. And the question of number 5 says, please convert these measurements into atom slash molecule. So before we go any further, is water an atom or a molecule? It's a molecule. So we're converting from grams to molecules. So the question that I have for you guys, just like I've asked every time, using this flow chart. So I would encourage you tomorrow when you're doing this, the first thing you want to write at the top is this. You don't have to do the Dothan, Atlanta, New York, but I would encourage you to write the blue stuff and maybe the purple stuff. Okay, that'll kind of help you out a little bit. So going from grams to moles to atom slash molecules. So we're going from grams to molecules. Can I do it in one step? No. You got it? You sure? Okay. All right. So we're going to start here, and we're going to set this up, and we know that we're going to have to go 2 steps. Again, I apologize about cramming that in like that. We know we're going to have to go 2 steps simply because we can't do it in one. Since grams is on top, where does it go? It's got to go on the bottom. Now, I'm trying to get to atoms, but who's the middleman? Who's always in between? Moles. So I know that I can go from grams to moles. Now, by doing this, what have we essentially canceled? We've canceled grams. Now, and again, we already know we can't do this, but I'm just going to ask this question anyways. Why can I not stop there and give you a final answer? The question was asking about molecules. Well, I'm only in moles, so I got to go one more step. So if moles is on top, where does it go? It goes on the bottom, and then I can abbreviate molecules as cules. Okay, so I know I can cancel out mole, and I'm left with molecules, which is exactly what I wanted. So here's the easy questions. No matter where it is or how many times you see it, anytime you see the word mole, what do you write beside it? 1. So I got to use it twice. No matter where it is or how many times you see it, what do you always write beside molecules? Okay. 6.02 times 10 to the 23rd. All right. In grams, where do you get your grams from? Periodic table. Now, the bad news about this one is that is there one box that has H2O in it? So you got to calculate its molar mass. However, this is water. So, do you know the mass of water? Very good. That's the only one I've asked you guys to memorize, is this one right here. So personally, I feel confident in you're getting better at setting it up. I think you're getting to the idea of knowing what to put where and how to put it and how to get it. Again, my biggest fear is your skills and your calculator and knowing what you're doing. See if you can plug all this in and see if you can get the right answer. Yes, sir. Absolutely. You will, for every test from here on out, this right here will be right in front of you. Okay, so don't worry about having the periodic table. It will always be there. In fact, since I gave you that sheet, I'll go ahead and pass these out. So take a second, see if you can calculate it. All right, so this bottom value in the calculator should be your correct answer. The bottom value. Now here's the problem. Here's what scares me. Is that first of all, how many significant figures are in your problem? 3. So I'm fairly confident if you got this right calculation, you're going to put 1.30. If you write that, right or wrong? Obviously the units in the formula, but why is this wrong? I am begging you guys. Somebody's going to do it tomorrow. Somebody's going to miss that. You're not going to see that pop up in your calculator, and you're going to miss it. So it's times 10 to the what power? 27th, and it's cules of water. No. No. It doesn't always work out that way. Preferably no. Preferably no. Any questions on this? Now's the time to ask. Any questions? Okay. Now that you have the periodic table in front of you, I want you guys to do 5B, the whole thing. The whole thing. Okay, so most of you are almost done, so I want to go ahead and ask this question. Number 1, I've went ahead and wrote Avogadro's number in there because I know no matter what, it's going to be Avogadro's number if it's atoms or molecules. But what is NF3 by definition? It is a molecule. Very good. Okay, so I'm going to go ahead and write my cules in here. And then, what is the mass of NF3? 71.01 grams. Right? The way you got that is 19.00 times how many? 3. And then you added the mass of nitrogen, which is 14.01, and that gave you 71.01. So then when we do the math on this, it's going to be 0.564 times 6.02 times 10 to the 23rd equals, then divided by 71.01, and that's going to give me that answer right there. Right? So what would we round this answer to? Okay, 4.78 cules of NF3. Is that right or wrong? Very good. Again, I'm begging you guys, make sure that you catch that at the very end. Okay? Whatever, same difference. All right, so let's look at an alternative version to this. And I'm going to do one with you guys. I'm going to let you kind of jump on your own on this one. So look at number 6A. 6A says, please convert these measurements into grams. So we're going from 4.076 carbon atoms into grams. So this is essentially the same thing we just did, but what? Backwards. Okay. So same setup, we're just going to do it backwards. So we're going to start with atoms, and I know I want to get rid of it, so where does it go? It's got to go on the bottom. And I know that I can't go right from atoms right into grams, so who do I have to go through first? Moles. Okay? I know that I can't stop at moles, so I got to keep going, and there's going to be my setup. So does everything cancel except for grams? Yep. Okay, so atoms cancels, moles cancels, and I'm left with grams, which is a good thing. No matter where it is or how many times you see it, what's always given to moles? 1. No matter where it is or how many times you see it, what's always given to atoms? Okay, 6.02 times 10 to the 23rd. Now for the mass on this one, is this an easy mass or hard mass? Easy, because it's just one box, right? And what is the mass of carbon? 12.01 grams. All right, this is the first time you've really had to do an extension of the division. So go ahead and plug it in and see what you guys get. Okay, see what you guys get. Okay. All right, this time, this is what you should have gotten at bottom value. So I multiplied across the top, then divided by Avogadro's number at the bottom, and I got what value correctly rounded. Very good. Very good. 8.132. Are there any scientific notation in this one? No. Look at the very end of your answer. Is there an E anywhere back there? No. Okay. And so it's 8.132 what? Fantastic. Grams of carbon. Grams of carbon. Try it again. If you did it, you got an E. You did it wrong. You cannot have an E anywhere in your answer. All right, so one last one. I should have already told you guys to do this, so I apologize. Go ahead and do 6B. 7.54 times 10 to the 15th sodium atoms, and see how many grams that's going to be. Okay, so do 6B. We're going to do that in just a minute. We're going to do that in just a minute. All right, so here's your answer in the calculator. I'm not going to write everything out, but here's what you should have gotten. You should have got 2.88 times 10 to the negative 7th. And here's why. I want you to think about this for just a second. Let's talk about logic. What does 1 mole of sodium weigh? Look in your parentheses. 1 mole weighs how much? Look in the parentheses. 22.99 grams. Do you agree with that? 1 mole weighs 22.99 grams. How many atoms are in 1 mole? 6.02 times 10 to the 23rd. That's all in your parentheses. Here's my question. Do you start with more or less than Avogadro's number? Less, because it's 10 to the 15th, not the 23rd. So think about this. If you start with less than Avogadro's number, is that more or less than 1 mole? Less than 1 mole. So if 1 mole weighs 22 grams, should you have more or less than 22 grams? You should have less. And did you have less? That is the right answer. That is the same answer. It's to the -7th. Remember, a negative exponent means a number less than 1. It just expanded yours out. Okay, it's the exact same answer. So if you move that decimal to the right 7 places, that's what you would get. Does that make sense? Okay. Because the other number is so large, it forced it that way. That's fine. Different calculators do it different ways. Yeah. Okay, so here's what I want to do. I want you guys to take the sheet that I just gave you, and I want you to flip it over to the back. Well, this to me is the back. It says question 6 and talks about aspartame. Has anybody ever heard of aspartame? What's it in? It's fake sugar. It's in Diet Coke. So it says aspartame is an artificial sweetener that is 160 times sweeter than sucrose, which is table sugar. This is the sheet that I gave you at the very beginning of class. It's on the back. That's it. It does look a little different. Yep. Okay. So it's 160 times sweeter than sugar when dissolved in water. It's marketed by G.D. Sorrell as NutraSweet. The molecular formula of aspartame is C14H18N2O5. That is the chemical formula of aspartame. So here's what I want you to do. I want you to calculate the mass of that thing. I'm going to go ahead and tell you. There's not one near that large on the test. This is one of the biggest ones you'll ever have to do. Okay? See if you can calculate the mass of that thing. If you can do this one, you can do those baby easy ones you're going to see tomorrow. If you can do this one, you can do the really easy ones. Okay, so here's what you got to do. I'm going to do this a long way, but some of you can do it in your calculator, and that's the great part if you can already do it in your calculator. So how many carbons are in aspartame? Okay, very good. 14. How many hydrogens? 18. How many nitrogens? And oxygens? 5. Very good. And we're going to multiply it by the mass on the periodic table. Okay, what's the mass of carbon? Very good. 12.01. Hydrogen? Very good. 1.01. Nitrogen? Very good. And oxygen? 16 even. All right, so now I know that this is 18 point what? 18? Okay, this is 28.02. What's 14 times 12.01? Okay, and what's 5 times 16? 80. Okay, all right, and so then what you do is you add all those numbers up. So plus, and then what's that answer? 294.34, and what's your unit? Per mole. So if I have 1 mole of aspartame, how much does it weigh? 294.34 grams. Yes, sir. Absolutely. I do not have to see this math. If you can do it in your calculator, that's what I want you to do, as long as you're getting it right. Okay? This is just something to show you that you can do it. This is a big, complicated one, but you can all do it. All right, so we know that that's going to be the maths. No, that's fine. Like I said, I don't need to see it. I just want to make sure. Yes. Come on. That's okay. All right, so question B says, how many moles? This is a bad way to say this. Scratch this part right here off. How many moles are in 10 grams of aspartame? So what are we starting with, and what are we trying to get to? Try again. We're trying to go from grams to moles. Real quick, you'll know what I mean when I do this. I'm adding a decimal point behind the 10. What does that make? What does that affect? Two significant figures. I just want to make it perfect, okay, or better. So I've got 10 grams of, I'm just going to write ASP. Okay. Now, if grams is on top, where does it go? It's got to go to the bottom. Can you go grams to moles in one step? Yes. Anytime, no matter where it is, what do you always put beside mole? 1. Where do you get grams from? Have you already done that? Yes. And what was it? 294 point what? 34. So what do you do in your calculator? Divide. So it's going to move the decimal place one place to the... Should move one place to the left, right? You get 29. Okay. Now, so what is that in significant figures? You do 10 divided by 294. Yeah, 10 divided by 294. Yeah. No, this is right. So it's 0.034. Okay. 0.034. What do you mean? Yeah, I did, but it's not going to make a difference. It's still that, isn't it? So that's your answer. And then what's your unit and your substance? If you want to write all that, but I'm going to be lazy and write ASP. Okay? See if you guys can do C by yourself. So we're starting out with 1.56 moles of ASP, and we're trying to go to grams. Can you go from moles to grams in one step? Yes, so we've got moles, we've got grams. What goes beside moles? 1, what's the mass? 294.34. So when you multiply those two numbers, what did you get as the final answer? Okay, very good. 459 grams of ASP. All right. Any questions on that? We're going to skip D, and we're going to go to E. I'm going to go ahead and tell you, tomorrow this is going to be the bonus question. This is going to be the most challenging one, and it'll make sense when we get there. Okay? So just kind of stay with me as we go through this. So here's the crazy part. We're going from grams of aspartame to what specifically? Now, why is that kind of odd? Okay. Is nitrogen a part of aspartame? Yes. This is what I call this. This is an atom. Anytime you put a colon between something, what does that mean? A ratio. Very good. This is an atom to molecule ratio. This will make sense when you see it. Everyone just kind of hold on and stay with me. It's going to look very similar, and then at the very end, it's going to kind of look a little odd. So we're going to do 1.2 grams of ASP. Okay. Now, we know we got to get to atoms specifically, so you know how to go that far. Every time we've gone grams to atoms, has it always been 2 steps? Okay, let's fill it in. If grams is on top, where does it go? Bottom. Can you go straight from grams right into atoms? No, what do we got to go to first? Moles. Okay. I can't stop there, so I got to go again. So what am I in? Moles. Okay. And here's where it's going to kind of get off track. Stay with me. Joules of ASP. And what does ASP stand for? Aspartame. So far, let's go ahead and fill in what we know. Anytime you see mole, what do you put beside it? 1. Anytime you see molecules, what do you put? Okay. Where do you get grams from? And what is it? So here's my question. Why can I not stop at this point? What was the question specifically asking you for? Atoms of nitrogen. What am I at? I'm at molecules of aspartame. This next step is the new step. You've never seen it. And this is what I call the atom to molecule ratio. And this will make sense. So I know that I can't stop here. And you already know this. But if I want to get rid of molecules of aspartame, where can I put it? Bottom. Molecules of ASP. And here's the next step. Remember how I told you that anytime you ever see moles, excuse me, I did that wrong. Sorry. It's atoms. Sorry. So did I. So this last part looks a little weird. We're talking about molecules of aspartame and then atoms of nitrogen. This is what I mean by an atom to molecule ratio. You've already told me. Is nitrogen a part of aspartame? Yes. How many? There are 2 atoms of nitrogen in every 1 molecule of aspartame. Think about that for just a second. Exactly. If the entire thing is aspartame, how many nitrogens do you have? If the question had been rewritten asking you about carbon, would it change the first step? Would it change the second step? Would it change the third step? What would it change it to? Very good. What if it asked about oxygen? What would it change it to? 5. So do you see what we're dealing with? If I have a basket of fruit and I've got 1 apple and 2 or 3 oranges, if I want to know how many oranges make up the whole basket, it's 3 oranges for every 1 basket. So for every 1 aspartame, you get 2 nitrogens. Do you see why I call this an atom to molecule ratio? Okay. So now we just got to do the math. So that last step is the challenging part of knowing what to do. So what you're really trying to figure out is, number 1, do my grams cancel? Yes. Do my moles cancel? Yes. I can't stop here, so I got to cancel it. So molecules of aspartame cancels, and I can go from aspartame to nitrogen simply because is nitrogen a part of aspartame? If it had asked about phosphorus, could you do this problem? That makes absolutely no sense because phosphorus is not a part of aspartame. Okay? The formula. So if I need to show it again, let's go up here and let's look. Where we got this from is right here. That's where it came from. So I'm glad you said that out loud because somebody else may not have figured that out. That's where the 2 came from. So what if it had asked about hydrogen? What would you have put in there? 18. So it's just how many atoms are in the formula. Yes, sir. Yeah, but it's in 1 molecule. So if you just have 1 molecule, you have 2 nitrogen atoms. Does that make sense? Okay. All right, so let's do this math. Let me scroll down here where it was. Pull this up. Drag it over here. Maybe nope, that's going to be even harder to deal with. All right, so on clear. So I've got 1.2 times 6.02 second EE23 times 2 equals divided by 294.34. There's your answer. So how many atoms of nitrogen do you have? 4.9 times 10 to the 21st atoms of nitrogen. Yes, ma'am. You do the exact same thing, except you would figure out how many carbons there are in that compound. Is it aspartame? What's the compound on that one? Huh? So there'd be 3. Okay. All right. There is a little bit of time left. With the time that you guys have remaining, I want you to do as many of these top problems as you can do on the front. Flip it over and just work as many as you can work. So if you have any questions, I'm here to ask or here to answer.